Welcome back. In this video, we're going to finish up chapter 9 by doing section 9.6, which is on solving equations that have radicals in them. As always, when we're solving equations, we're going to end up with numbers for answers rather than other expressions. So there's that. And remember that a solution of an equation is a number that makes the equation true when you replace the variable with that number. Okay, so let's start. A radical equation, which is what we're working on, is an equation that has a variable in the radicand. And there's other kinds of roots, which we've kind of mentioned before, cube roots and so on, but we don't deal with those in now. Just square roots. So you could say a square root equation or radical equation. And for our purposes, those two are the same. Okay, as a reminder, answers in this section are going to be numbers rather than variable expressions. Okay, so just to get it started, we're going to check and see if -2 and 3 are solutions of the equation square root of x plus 6 equals x. Now, that is, you substitute the number in and see if you get something true or not. So I'm going to start with -2. We'll check that one. So we have -2 plus 6 equals -2. And this is the square root of 4 equals -2. The square root of 4 is 2. Does 2 equal to -2? And it doesn't. So that looks like no, it is not a solution. Let's check 3 next. So we're going to have the square root of 3 plus 6 equaling 3. 3 plus 6 is 9. We have the square root of 9 equaling 3. The square root of 9 is 3. 3 equals 3. That looks like yes. So in the first case, the -2 was not a solution. 3 is a solution. All right, so the basic steps for solving a root equation are to square both sides. So we'll say that if a is equal to b, then a squared equals b squared. If you take the two sides of an equation and square them both, you get two things that are equal. And you square a square root, that gets rid of the square root sign, and that gives us access to the variable underneath. So we're going to try that with this one, the square root of 3x minus 5 equaling 5. So we'll take the square root of 3x minus 5 equaling 5, and we're going to square both sides. If you take the square root of 3x minus 5 and square that, you should just get 3x minus 5. The right side will be 5 squared, or 25. Solving for x, we'll get 10. Okay, and then you can substitute that into your equation and check. You can do this one mentally, actually. 10, let's drop that into our equation. 3 times 10 is 30. 30 minus 5 is 25, and the square root of 25 is 5. So yes, the solution this time is 10. Okay. And then let's try that again. Here's one for you to try, actually. Take a minute, pause the video, try this one yourself, and then restart the video and see how you did. Okay, so before you square both sides, you're going to want to isolate the radical. So on this one, I hope you didn't try squaring both sides right away. We have the square root of 5n minus 4. I'm going to set that equal to 9. Here we're adding the 9 to both sides. So that gets the root by itself. Okay, now we're going to square both sides. So we'll have our square root of 5n minus 4 squared equaling 9 squared. The square root of 5n minus 4 squared just gives us 5n minus 4. And then n squared, 9 squared is 81. So this gives us 5n is 85, and so that means that n is 17. Our solution is 17. So basically, you want to isolate the square root, and then you want to square both sides. All right, let's try this one next. Here we have the square root of 3x plus 2 minus 5 equaling 0. So this time you're going to know right away that you should add the 5 to both sides. We're going to take and square both sides. So you'll have 3x plus 2 equaling 25. 3x is 23, and x is 23 thirds. Okay, so our solution here is 23 over 3. All right, so that's pretty fun. So let's see what else we can do. All right, here we have the square root of 2y minus 3 equaling, or plus 5 equaling 0. So on this one, when you go to isolate the square root, you're going to have the square root of 2y minus 3 equaling negative 5. For this one, you can just stop right here and say there's no solution. And the reason for that is the principal square root, which is what we've got here, is always non-negative. It's always 0 or more, so there's no chance of it ever equaling negative 5, no matter what you plug in for y. So you could say no solution. You could give the empty set is either that fat zero with a slash through it, or curly braces with nothing in between. So there's no solution here because the square root of whatever is always greater than or equal to 0. And so it will never equal negative 5. So there's just no number that will do it. Okay, so let's try this next one next. So we have the square root of x plus 2, sorry, x minus 2 plus 2 equaling x. So we're going to want to isolate the radical on this one. Okay, so first thing to do is subtract 2 from both sides. That will give us x minus 2 on the right. In the next part, we're going to square both sides, as we've done before. Make sure when you square both sides that you do this as a whole binomial that we're squaring. You shouldn't end up getting x squared minus 4. Okay, don't just square the x and square the 2 going around squaring things term by term. It doesn't work that way. It'll be x minus 2 all squared. Okay, on the left side, we have the square root of x minus 2 squared. That will give us x minus 2. And then on the right side, the x minus 2 squared is x squared minus 2x plus 4. Okay, let's collect all of the numbers on one side of the equation. So we'll have x squared minus 3x plus 6. Let me double check my work. Okay, let's check that. All right, so I made a mistake here. First of all, how I knew I made a mistake, and then I'm going to fix it. So how I knew I made a mistake is that we ended up with a quadratic equation here, and the only quadratic equations we've seen how to solve so far are the kind where you can factor. And this one, x squared minus 3x plus 6, you're not going to be able to factor that. To find two numbers that are the same sign and both negative, multiplying the 6 and adding up to negative 3. This guy doesn't factor. What I did wrong with it was I messed up in my multiplication. So the x minus 2 squared, the middle term shouldn't have been minus 2x. It should have been negative 4x. So let me fix that. Okay, so if you're following along, I had a 2x there. It should really have been a 4x. Okay, and so I'm sorry about that. Knowing our limitations is a good idea. In this case, I don't know. We, at this point, officially only know how to solve quadratic equations by factoring. And since I came up with something that I couldn't factor, that told me I must have made a mistake someplace. All right, let me try that again. So we'll have 0 is x squared minus 5x plus 6. Now that looks better. That's something that does factor. So while it still could be wrong, at least it does factor. So let's check. That's how this factors. So it looks like our two solutions would be x minus 2 equals 0, x minus 3 equals 0. So x equals 2 or x equals 3. Mostly. I'm just going to say mostly because we need to check our solutions in this equation and make sure that they actually do work. And so let's do that, and then we'll talk about why that's the case after. So we're going to first check our, let's check 2 first. Okay, we're going to put 2 into this equation. We'll have the square root of 2 minus 2 plus 2 equaling 2. Square root of 2 minus 2 is the square root of 0. The square root of 0 is 0, so we'll have 2 equals 2. So that looks good. 2 works. All right, and then let's check R3. Maybe they will both work. Find out. The square root of 3 minus 2 plus 2 equals 3. 3 minus 2 is 1. This one will work. Okay, so that worked out. So there are actually 2 solutions to this one, 2 and 3. With radical equations, you can get differing numbers of solutions. Sometimes no solution, often 1 solution. Sometimes, as with this one, we got 2 solutions. The fine print here, when you're squaring both sides of an equation, you need to check any possible solution you can get. Of course, in math class, we always tell you to solve or to check your solutions, and that's just to check for mistakes. This procedure of squaring both sides, it's actually necessary to check your solutions, and here's why. When we first learn about solving equations, there's certain things that we learn that are okay to do. When you're solving like x plus 3 equals 10, we all know that you could subtract 3 from both sides without hurting anything. If you have 2x equals 18, you know, okay, well, I'm going to be able to divide both sides by 2. So you can add the same thing on both sides. You could divide the same thing on both sides. You could multiply the same thing on both sides. Let's say you knew that 1/3 of x was 14. You'd multiply both sides by 3. You can add, subtract, multiply, and divide on both sides without hurting anything. By hurting anything, I mean making it so that we lose a solution or pick up some number that is not really a solution. So those are safe in that sense. This procedure of squaring both sides of an equation isn't safe in the same way. And so let's see how that might, an example where that's can happen. All right, so let's say that x is equal to 7. If I asked you to solve this equation, you'd probably wonder why I was asking, because of course it says right there that x is 7. But when we're solving, we're finding the number that when you replace the variable with that number, you get a true statement. So although it's a dumb question, we're going to ask, what number should I replace x by to make this true? You should replace it by a 7, right? That should be an easy question. If I change the x into a 7, it's going to be true. If I change the x into any other number, it will be false. So here the solution is 7. And that's it. There's no other numbers that will make this true. Now, let's go through and square both sides. If I square both sides, we'll have x squared. And then 7 squared is 49. Squared both sides. Is 7 a solution to that? Yes. If you replace x by 7, 7 squared is 49. So you still have that solution. But notice also now there is a number -7 that is also a solution to this equation. -7 squared is 49. That's a solution to this new equation that isn't a solution to our original equation. -7 here is what's called extraneous. There's, extraneous. There we go. It's what's called an extraneous solution, meaning it's a solution to our new equation, but not a solution to the original equation. And so that can happen. It didn't happen up here, but it's going to happen in a minute. For that reason, whenever you're squaring both sides of an equation as part of a solving process, then you do have to check both sides. Check the solution in both sides to make sure that it ends up being equal. All right, so let's try one more example. We're going to first take the square root of x plus 9 and leave it on the left side. And the other stuff we're going to put onto the other side. So we'll have equals x minus 3. Okay, so now we want to go through and square both sides. So we'll have the square root of x plus 9 squared, and that's equal to x minus 3 squared. The square root of x plus 9 squared will just give us x plus 9. On the right side, I'll be more careful this time. We'll have x squared minus 6x plus 9. Okay, so then let's go ahead and collect all the terms onto one side so that it's set equal to 0. We can then factor and use the zero product property. We'll have x squared minus 7x, and then the two 9s are gone, right? So here we'll have 0, equals x times x minus 7. Okay, so then here it looks like our two potential solutions are 0 and 7. So we're going to have to check those two and see if either or both of those work. So let's going to try x0 first. So let's put that in our equation. We'll have 0 plus 9 minus 0 plus 3, and we need to make sure that that ends up being 0. Okay, 0 plus 9 is 9. We have the square root of 9 minus 0 doesn't do anything. Plus 3 is 0. The square root of 9 is 3. 3 plus 3 equals 0. That doesn't sound good. So 0 is not a solution. It's a solution to the quadratic equation, but it's not a solution to our original radical equation. Okay, so let's try 7 next. Okay, so we'll have the square root of 7 plus 9 minus 7 plus 3. And that had better turn out to be 0. So let's see. This 7 plus 9 is 16. And the square root of 16 is 4. This one's looking good. 4 minus 7 is negative 3. And negative 3 plus 3 is equal to 0. Okay, so that works. This time our only solution is going to be the 7. When you're solving radical equations, always want to check and see if there are extraneous solutions. So here's one for you to try. Go ahead and pause the video and try this one, restart the video and see how you did. Don't forget to check for extraneous solutions. All right, so I started while you were working. So the first thing I did was I added 16 to both sides, and then I divided by 2. So I have the square root of 4x plus 2 equaling 16. And so we're going to take and square both sides once again. 16 squared is 256, okay? So this will give us 4x plus 2 on the left side and 256 on the right side. So this will be 4x is equal to 254. And so this will be, I think, 127, but I will check. We're dividing 254 by 4. I think it's 157, but let's see. That was way off. So that's like 36 and change. So 256 divided by, or 254 divided by 4. Or 120, there's 127. That's 127 divided by 2. Okay, let me just double check that. Yes, that worked out. It's just the fraction was a little weird looking compared to what we're used to. So I just want to make sure that there wasn't a mistake in there. But yeah, that worked out. And there was only one value in here, and I checked it in our equation, and it was true. So no extraneous solution that time. All right, let's try one more, or we've got 2 more, and then we'll be done. So we have the square root of x plus 3 equaling the square root of x plus 5. So we're going to, again, begin by isolating the radical. Of course, there's 2 radicals in this one, and so you can ask yourself, which one do you want to isolate? It won't matter in the long run, but this one, the right side already has a root by itself. And so we're just going to go ahead and square both sides right now. So when you take the square root of x plus 3 and square it, remember that this isn't going to be x plus 9. Okay, you need to use the perfect square trinomial formula or FOIL or something in order to multiply out that left side. It's not going to be x plus 9. You have the square root of x plus 3 times the square root of x plus 3. That will be for the firsts an x, for the outers a 3 root x, for the inners a 3 root x, and for the last a 9. Get x plus 6 square roots of x plus a 9. on the left side. On the right side, it's nicer. It's x plus 5. Okay, so this is our first example where we've squared both sides and yet there's still a radical in there. What you do when this happens is you isolate the radical again and square both sides again. And you just keep doing that until the root is all gone, and eventually it will be. For our purposes, we'll never have to square more than 2 times. Okay, so here I can take an x off of both sides. That's pretty great. We'll have 6 root x plus 9 equals 5. And then taking away the 9, so we'll have 6 root x. Taking away the 9, this will give us a negative 4. And it looks like root x is negative 4/6, which is negative 2/3. And so from here, it looks like there's just no solution. Remember that this square root is always greater than or equal to 0. It will never equal negative 2/3. All right, so that's kind of unsatisfying after all that. We didn't need to square both sides, as it turns out, as we ended up with the right side just being negative right away. All right, so that was it for that one. Hopefully this one will be more exciting. For this one, once again, the right side is already, the radical is already isolated. So we will just jump right in and square both sides. This is probably the hardest kind of problem that in this section that we will see. So if you find it rough going, at least take comfort in knowing that it won't get any worse than this. Right, so we have the square root of a minus 4 plus 5 squared. So we'll have the square root of a minus 4 squared gives us a minus 4. And then twice the product of the two things. So we have 10 square roots of a minus 4. Then in the back, a 25. And so what happened there, if you lost track, is we were using the perfect square trinomial formula from before. That looks like a plus b squared is a squared plus 2ab plus b squared. So what was playing part of the a in this formula was our square root of a minus 4. That squared gave us the a minus 4. Then we had plus, and then 2 times the two things in our binomial. 5 times root a minus 4 times 2 gave us 10 root a minus 4. And finally, the b squared is the 5 squared, or 25. Okay, and then right on the right side, nothing happened, so everything is okay. All right, so here, clean up the left side a little bit. Let me combine the negative 4 and the 25. Okay, and then I've simplified the left side as much as I can for now. We want to isolate the radical again, so let me subtract the 21 from both sides. That'll be 3a minus 18. I'm just going to try to go step by step, so I'm less likely to make mistakes. Let me subtract the a from both sides. And then next we'll divide by the 10 in order to get that root by itself. Okay, and then there I can see on the right side there's a common factor of 2 that can be eliminated. So that will give us a minus 9 in the top and 5 in the bottom. So up to this point, we're ready to square both sides. So let's do that. So this will give us the square root of a minus 4 squared. And then on the right side, we'll have a minus 9 over 5 squared. And now continuing onward, the square root of a minus 4 should give us a minus 4. On the right side, up top, we'll have a minus 9 squared. And then down below, 5 squared is 25. Okay, let's keep going. I'm going to multiply both sides by 25 here. So we'll have 25 a minus 100. Let me do this in 2 steps. Okay, that's 25 times a minus 4. And then on the right side, we'll have a squared minus 18a plus 81. Okay, so then multiply to clear parentheses away. That's going to be 25a minus 100. And then this will be a squared minus 18a plus 81. Okay, so now I need to collect everything on one side, set it equal to 0, and then we'll try factoring. All right, so then we have negative 18a already. We're going to subtract 25, so that's 3843a. And then on the right side, we have 181. All right, that doesn't sound so good. So let me check and see if I've made a mistake somewhere, because looking at that, it doesn't look like something I'm going to be able to factor. So let me put that out. All right, so I checked this one out like a few times, and sadly on this one, it just doesn't factor. I took this problem from the book, and sometimes there's typos. So at this point, this one you would be able to find out solutions if we were in chapter 10, but as we're in chapter 9, we cannot. So that's it. Sorry about that. I'm going to do one more that will work out, and we'll finish with that. All right, so for this one, we have the square root of y minus 2 plus 2 equaling the square root of 2y plus 4. So on this, what we will do first is square both sides. So we'll have our square root of y minus 2 plus 2 squared. And then on the right side, the square root of 2y plus 4 squared. All right, so then on the left side, we're going to multiply out that as a perfect square. The first part squared will give us y minus 2. And then twice the product of the two terms in our binomial. So that'll be 4 square roots of y minus 2. And then in the back, 2 squared is 4. On the right side, we'll have the square root of 2y plus 4 squared, which will just give us 2y plus 4. All right, so at this point, what we want to do is simplify things as much as we can. We'll isolate the radical and square both sides a second time. So I'm going to subtract the y from both sides, and also, let me do this in 2 steps, okay? So let's subtract the y from both sides first. Okay, we're going to combine the constants that are on the left side. Negative 2 plus 4 will give us a 2. Okay, and now finally subtract the 2 from both sides. 4 square roots of y minus 2 equals y plus 2. And then let's divide out that 4. So we'll have the square root of y minus 2 equaling y plus 2 over 4. So at this point, we'll go ahead and square both sides. So that will give us y minus 2 on the left side. I guess the parentheses are not needed. Here on the right side, up top, we'll have y squared plus 4y plus 4. And then that's on top of 16. Let's multiply both sides by 16 to clear the fraction out. So we'll have 16y minus 32 is equal to y squared plus 4y plus 4. All right, it's getting there. Let's collect everything onto one side, and then we should see that it factors. We'll have y squared minus 12y plus 36. And so this looks like it's a perfect square, right? So this is just y minus 6 squared, and so 6. Okay, since we squared both sides, we better check. In fact, we squared both sides twice, so we really should check. It looks like our potential solution is 6. Let's go back to our equation and check. So that's 6 minus 2 square root plus 2 is equal to the square root of 12 plus 4. Okay, so 6 minus 2 is 4. Square root of 4 plus 2 is equal to the square root of 16. The square root of 4 is 2. 2 plus 2 is 4. So we do have 4 equal 4, and it checks out. So at long last, we got the solution to this one, at least, and the solution is 6. So that takes us to the end of section 9.6. Let me know if you have any questions, and have a great day.